Hi. In the first section of the Learning Plan 1 seminar, I would like to spend some time on Bayes' theorem. Chapter 2 of the textbook provides a really nice overview of the probability theory, including Bayes' theorem, but I would like to spend more time in covering Bayes' theorem because of its popularity in decision-making applications. So I have prepared some formulas of the Bayes' theorem, and with some explanation, I'm sure it will make sense what is the implication of Bayes' theorem. Bayes' theorem combines the information on prior probabilities with the outcome, likelihood of the experimental outcomes to update the posterior probability. It might sound a little bit complicated, but on the example, utilizing example, we'll be able to clarify the implication of Bayes' theorem. So let's imagine we have two mutually exclusive events. A person has a disease and a person doesn't have a disease. So those are two mutually exclusive events. And how we determine whether a person has a disease or not? Certainly, we conduct a test, and each test has error associated with the test results. Person might have a disease and test wouldn't signal, and person might not have a disease and test would signal. The likelihood of outcome being given state of the world in this case is that experiment based on which we obtain information. What is the probability that the positive test results came given a person has a disease and positive test results were obtained given a person doesn't have a disease. Each specific test, given a review and analysis of all available historical information, you could obtain those probabilities. So given these probabilities and given the prior probabilities, what is the probability that a person has a disease? So that could be that information could be obtained again from the review of the medical records and healthcare organization of that particular country, and basically this is the percentage of the population which has a disease and percentage of the population which doesn't have a disease. All this information could be obtained utilizing the analysis. So again, combining the likelihood of the outcome, outcome B, in this case positive test results came up, given a person has a disease with prior probabilities and probability that positive result came given person doesn't have a disease, with combining with probabilities of the population which doesn't have a disease, we could obtain the probability, posterior probability that a person has a disease given that a positive result came up. So that's the generic implication of the Bayes theorem. We will cover an example in the next section that will hopefully make more impact on the clarification of the Bayes theorem. Okay, see you in the next session.